Okay, Peter, tell us about this. This is where the water's coming in from where the storage tank?
From the wells. No, this is the raw water line coming from one of the 3 wells that are located down in Ford City. So they, depending on what day of the week or which well the operator selects, water gets pumped up from town to the plant here. The first step in the process is the raw water comes in, and some of it goes through these 2 water softeners. These are basically the same thing you might have in your house if you have a Culligan system. These are just on a much bigger scale. So we'll soften about 500 gallons per minute of water through this. And we do this by sending some of the water through the softener and blending raw water with it to get soft water levels that have a hardness below 300.
Where's all the salt tanks? If it's like the one that I have at home.
The salt tank is that opaque tank right behind it. So the operators will keep that full of salt, and once every couple of days we'll regenerate the softener.
So how much do you plan as far as how much salt does it take on like a monthly basis to make
They're
this
probably looking at maybe 500 pounds a month, we're guessing. Right now, being that it's brand new, we're not 100% sure on some of the, the exact amounts. We need to let it run for a little bit. Obviously, if you get really wet weather and the hardness comes up, they'll use a little more salt. If the hardness goes down, we'll use a little less salt. But I think 500 pounds is probably a good starting point. Yeah, once it hits the white line, we call it softened water. So it's been through the softeners, and it goes from the softeners into one of these 2 big tanks. And these are just intermediate storage tanks. So they will, they'll fill up, and once they reach a certain height, we start the RO units. These pumps kick on and transfer water from the intermediate storage tanks to the RO units.
Now, you're saying RO, I'm not familiar with that.
Oh, it's a reverse osmosis.
Okay, now is that this or that?
That's that. Everything from...
So these are pumps here.
These are just pumps. We're just pumping water. Yeah, just pumping water from the tank to the RO unit.
Okay.
What the RO unit is, they have 10 rows of membranes. So the whole purpose of the RO is to reduce the total dissolved solids in the water. And we do much the same as the softener. Some of the water goes through the RO, some goes through a bypass, but the blended combination at the end has the total dissolved solids much below the state limit. And we can vary that number with our blend ratio. So we can change that. If the total dissolved solids go up, we blend a little less. If the number drops, we blend a little more. And ultimately, in the end, the water leaves here and we'll head to the back corner of the building.
So this is just purification.
That's purification. Yeah, it's basically a very high-tech filter. So it's filtering out particles at the atomic level right now. Ultimately, the water, once it goes through the RO, will go down this pipe called the finished water line, and it goes out to the 1.5 million gallon storage tank where it'll be ready for consumption.
Now, is that the big thing we see out there that stands up high?
No, that's the high service tank that feeds the, let's call it Ford Cliffs in this high area. There's another 1.5 million gallon storage tank on the other side of the old plant. All of that water goes into town by gravity.
Is there any changes being made to that? Or
we painted the elevated storage tank both inside and outside as part of this project. Okay. So last fall it was completely painted, sandblasted and painted.
So is there, the big thing was that there was this, so the other building that's right beside here, is that torn down?
That's the old plant, yes, it'll be torn down as soon as this one's fully operational.
Okay. How long do you think it takes to put this one fully operational?
Well, we need, right now we could run it and we could be making water. We're just waiting on the DEP engineer to do his inspection and issue the operating permit. And once we have that permit in hand, we'll switch over operation to this plant.
From a design and functional standpoint, were there any specific parts of this that were, a little bit more complicated because of the way the plant's being designed?
The complication here was really trying to incorporate an RO unit in for the reverse osmosis unit for the total dissolved solids reduction. The wells here are very good quality. They were just a little bit above the state level for total dissolved solids, and really the best applicable application we could find was to use an RO unit. So, and then it's the electrical integration of trying to get all these units working together, and once the plant's running, it'll be completely automated. So, it can turn itself on, off, but there's a lot of safety catches to make sure when it turns itself on by itself, everything comes on in the correct sequence and works the right way and ensures the water quality.
We know the old plant, I believe, was 70 plus years old.
At least.
Yeah, so here, this one, in its current configuration, before you're going to see some, really strong maintenance of it, how long does this expect to last?
Oh, I would say at least, with maintenance, it should last a long time. I mean, same as the last one. The big maintenance item here, or what I'll say is a consumable, are the reverse osmosis membranes. They have a 5 to 10 year life cycle. So, somewhere in that, we're guessing around 7 years, they'll need to be changed out. But
costly.
Not terribly bad. It's a very fixed maintenance cost. We know what the price of those is going to be, so it's something that's easily budgeted. It was taken into account during design that Ford City's revenue from the water system can easily sustain it. So it won't be a shock when that needs to happen. So that's pretty much the reverse osmosis system. And just like any other treatment plant in the country, Ford City will continue to use chlorine to disinfect the water. And it's a DEP and EPA requirement that there is a disinfectant in the water. So we've got 2 chlorine pumps here. And they're set up that if one should fail, the other one will automatically turn on. You do have mechanical issues from time to time, but the chlorine pumps can switch back and forth. Then right next to that, we have actual chlorine analyzers. So we're checking the chlorine level continuously, both as it leaves the water plant to ensure that we're actually putting chlorine in the water, but also from the big 1.5 million gallon storage tank, we're checking chlorine again before it goes into town to make sure that the water is safe as it heads down the hill.
Now, what about, I know in the old system you had fluoride. Is that still part of this one?
Yeah, we're doing away with the fluoride, and I believe they've already done that. We had the public hearings on that well over a year ago to remove fluoride. The new plant will definitely not have fluoride treatment in it. The only chemical we're adding is chlorine.
And you're saying we have a unit sitting over here.
Right. This is periodically, every 4 to 6 months, the reverse osmosis membranes will foul and become less efficient. So this unit, depending on what the foulant is on the reverse osmosis, will fill this tank up with hot water and a strong acid or a strong base, and we'll flush it through the unit for probably an hour or two to it'll dissolve off any fouling. Then we bring that chemical back into this tank and flush the units out with clean water. Takes a few hours, and then we return them back into service.